In this section, we're going to talk about the properties of ionic compounds. Even though in the last section I talked about there only being one magnesium for every one oxygen or one magnesium for every two chlorines, that's simply a ratio between the two ions in the salt. For example, the magnesium chloride had a ratio of one magnesium for every two chlorines. What really happens in salts is they form a crystal lattice, like you see here. This crystal lattice is lithium chloride, and you'll notice it takes one lithium for every one chlorine. That's simply a ratio. There might be 10 lithiums for every 10 chlorines, or 20 lithiums for every 20 chlorines, or maybe a million lithiums for every 1 million chlorines. But it's a ratio. And you'll notice that all the positive lithiums are attracted to negative chlorides all over that salt crystal. Some of the properties of ionic compounds is that they have a high melting and high boiling point. They also conduct electricity in two situations, either when they're melted or if they're dissolved in water. If you take a salt and dissolve it in water and it conducts electricity, it's called an electrolyte. They're also hard, rigid, and brittle. Let's go a little bit further into something called lattice energy. This is the measure of the strength of the bonds in an ionic compound. If you look below, we have a mole of sodium chloride. Now you don't know what a mole is yet, but it's just a very large amount of sodium chloride. In order for us to break those ions apart into their individual sodium and chloride ions, it's going to take some energy. This amount of energy is 787 kilojoules. Some salts will require less energy than that. Some salts will require more energy than that. Coulomb's law helps us determine the amount of lattice energy in a salt. You have Q1 times Q2 over R. The Q1 and Q2 represent the charges on each of the ions in the salt. The R is the average atomic radius of those ions. Since the major determining factor of lattice energy is its charge, we're going to ignore the radius in some of the problems we're going to try here. Here we have two salts, and we're going to determine which one has the larger lattice energy. The way we're going to do this is just take the individual charges of each ion in that salt and multiply them together, as in Coulomb's law. Notice we're going to ignore the radius in this situation, so this is just an estimate to see which one has a larger lattice energy. Sodium chloride is made up of two ions, sodium and chlorine. The sodium has a +1 and the chlorine has a -1, so we multiply those together like so. If we multiply those two together, we get a -1. That doesn't make any sense to you right now, but let's look at the next one. Magnesium and oxygen, if you write down their charges, magnesium has a +2, oxygen has a -2. If you multiply those together, you get -4. In order to determine which one has the larger lattice energy, you take the largest negative number. A +2 will be way more attracted to a -2 than a +1 is attracted to a -1. There's more physical pull between the two ions, so they must be harder to break apart. So the magnesium oxide, having a -4 for our lattice energy, has a larger lattice energy. It also means, since it's harder to break them apart, it has a higher melting point and a higher boiling point.